In this section, we're solving equations that contain rational expressions or algebraic fractions. In this first example, we have x over 2 plus 3x over 4 plus 5. This should be equals. Right? And most students don't like fractions, so our objective is to get rid of these fractions. How can we get rid of these fractions? Well, if we get rid of these denominators, we would no longer have fractions. How can I get rid of those denominators? I could find a value that would cancel both of those out, a value that both 2 and 4 could go into. The first thing I want to do is I want to identify the LCD. In this case, it looks like my LCD would be 4. My lowest common denominator, 2 goes into 4 and 4 goes into 4. I could then multiply all the terms by the LCD. So I want to multiply this first term by 4, the second term by 4, and even the 5 by 4. Remember, when we're multiplying by 4, it's really like 4 over 1. So 4 is up high in the numerator. Now we could cancel out the denominators. Right here, 4 and 2, or 2 goes into 4 2 times. 2 times x is 2x. Here I have 4 over 4, which is 1. 1 times 3x is 3x. And 5 times 4 is 20. Now I no longer have fractions in my equation, so I could solve like regular. Well, in this case, I have x's on both sides. I like to get rid of the smaller one, but in this case, I don't know if that makes sense. Maybe it's better to bring the 3 over. Let's see what happens if I don't get rid of the smaller one. Minus 3x minus 3x. I have a negative 1x is equal to 20. That's why I usually get rid of the smaller one, so I don't have that negative. But it's okay to have a negative 1 there. I could just divide both sides by negative 1, and I'm going to have x is equal to negative 20. So we found the LCD. We multiplied all the terms by the LCD in order to cancel out the denominators, and then we solve resulting equation. So let's try this next example. You might want to pause right now and try this on your own. Otherwise, I'm just going to move forward. I'm looking for my LCD in this case. So my LCD is a value that 5, 2, and 3 can all go into. Looks like it's going to be 30. Seems kind of large, but so I want to multiply everything by 30. I said it seems kind of large, but even if it is large, a lowest common denominator is ideal. But if you just find a common denominator, that's fine also. So 5 goes into 36 times. So now I have 6 times 3. This gives me 18x. 2 goes into 30 15 times. So I have 15 times x minus 3 equals 3 goes into 30 10 times. So I have 10 times x plus 2. I no longer have fractions. I could solve this by distributing. So I'm going to have 18x minus 15x plus 45 is equal to 10x plus 20. combine my like terms. I have 3x plus 45, 10x plus 20. I'm going to move my x to the left side again. Minus 10x, minus 10x. So it looks like I have negative 7x plus 45 is equal to 20. Minus 45, minus 45. I have negative 7x is equal to a negative 25. I divide both sides by negative 7. Oops. So x is equal to 25 sevenths. Here's another example. What makes this example different than the examples prior? There's a big difference here. In this case, I have x in the denominator. If I have a variable in the denominator, that forces restricted values, because there are certain values that can't exist in the denominator of a fraction, right? 0 cannot be in the denominator of a fraction. It creates an undefined value. So anytime you have an x variable in the denominator of a fraction, you're going to have to set restrictions. Values that x cannot be. When I solve this problem and I get a value for x, there are certain values that x can't be equal to, because if they're equal to it, it'll create an undefined value. So in this case, I could see pretty clearly that x cannot equal 0, because if x were to equal 0, I would have 0 in my denominator there, and I'd have 0 in my denominator there. So if I were to solve this and x were to be equal to 0, it would be no solution, because I wouldn't be able to check it. I wouldn't be able to substitute it back in. So let's continue with this problem. After we set the restrictions, we're just going to go about this the same way. We want to find an LCD. My LCD in this case looks like it's going to be 3x. So I want to multiply each one of these terms by 3x. Then I could cancel out my denominators, just as we've done before. So I'm going to have 15 is equal to 10 plus 12x. And now I could solve my resulting equation. So I'm going to subtract 10 from both sides. I have 5 is equal to 12x. Divide both sides by 12 to get x by itself. And it looks like x is equal to 5/12. You see that? It looks blurry. So let's look at this next example. In this next example, similarly, I have x in the denominator. I don't care about x in the numerator. I care about x in the denominator. So I'm going to have to set my restrictions, what values x cannot be. In this case, x cannot be equal to 2. If x were to equal 2, I would have undefined values. I want to find my LCD, which in this case is x minus 2. Now I want to multiply each term by my LCD in order to cancel out the denominators. So here I'm going to be left with 2x minus 2 times x minus 2. And now I could solve my resulting equation. I want to remove my parentheses by using distribution. Then I want to combine my like terms. I want to get x by itself, so I want to subtract 4 from both sides of the equation. I have negative x is equal to negative 2. I want to get rid of this negative, or call it a negative 1 in front. So I'm going to divide both sides by negative 1. So x is equal to negative 2 divided by negative 1 is positive 2. Therefore, there is no solution, because we already stated that x cannot be equal to 2. And if I substitute this back in, I will not be able to check it. It's not a solution. It doesn't make the statement true. So that's why you want to set a restriction. To see if your final answer matches your restriction, then it's going to be no solution. Here's two more. These will be our last two examples. These look pretty lengthy. This first example, I want to find my LCD. In order to find my LCD in this case, I'm going to need to factor denominators. So really, the only one that could be factored is this one. So I want to rewrite this as 6 over x plus 3, 5 over x minus 2 is equal to negative 20 over 3 times 2 is 6, plus and minus. So let's factor denominators. Once I factor the denominators, I could set my restrictions. There's certain values that x can't equal in this case. I could see in this case x cannot equal negative 3. X cannot equal over here a positive 2. X cannot equal negative 3, which I already have, and x cannot equal positive 2. So, okay, my only two restrictions are right here. Once I have those two restrictions, I can find my LCD. My LCD in this case looks like it's going to be x plus 3, x minus 2. So I want to multiply each one of these by x plus 3, x minus 2. In order to cancel out the denominators, I want to multiply through by the LCD. So now I could see my x plus 3 cancels out with my x plus 3. This will give me 6 times x minus 2. Here my x minus 2 cancels out with my x minus 2. So I have negative 5x plus 3 is equal to, that whole denominator cancels out, leaves me with 20, negative 20. I no longer have fractions in my equation, so I could solve this resulting equation. 6x minus 12, negative 5x minus 15 is equal to negative 20. So it looks like I have x minus 27 is equal to negative 20. So if I add 27, I'm running out of space. So it looks like x is equal to 7. It's not a restricted value, so it works. I add 27 to both sides, if anybody's wondering where that value came from. Maybe you want to take a second, try this next example on your own. Maybe pause it. If not, I'm just going to move forward. This is 4. I want to factor my denominator. Going to factor my denominator. Factor my denominator. I have x plus 5, x minus 2, x plus 3, x minus 2, x minus 4, x plus 3. Once I factor my denominator, I could state my restrictions. X cannot be negative 5. X cannot be positive 2. X cannot be negative 3. X cannot be positive 2. I already have that. X cannot be positive 4, and X cannot be negative 3. So these are all my restrictions. X can't be any of those values, otherwise there's no solution. If we end up solving and it's one of those values, it's a no solution problem. My LCD in this case looks like it's going to be a nightmare. My LCD is going to be 4 terms, or 4 binomials. X plus 5, X minus 4, X plus 3, and X minus 2. Right? So I want to multiply all of these terms by that LCD. Now it's kind of sloppy, but you could just say what's missing from there to there, however you want to do it. If you choose to write the LCD above each one, it would look something like this. So now we could cancel out x plus 5 and x plus 5, x minus 2 and x minus 2. So I'm going to be left with 4 times x minus 4, x plus 3. I'm going to run out of room. Here, the x minus 2 and x minus 2, x plus 3, so I'm left with negative 1 times x plus 5, x minus 4, equals 3. My x minus 4 and my x plus 3 cancel out, so I have x plus 5, x minus 2. And now I'm going to multiply all of this out, FOIL these out. We got to get rid of all these parentheses, so we want to multiply those binomials. So if you FOIL these out, x squared, 3x, negative 4x, and negative 12, and then you combine your like terms, that will give you your b term. Same thing here, same thing here. Now you want to distribute to remove your parentheses, so we're going to take what's on the outside and multiply it to all the values on the inside. I distribute the value on the outside of the parentheses to the value on the inside of the parentheses, and I get this disaster, right? Now all I have to do is combine my like terms on each side. So here it looks like I'm going to have 3x squared minus 5x minus 28 is equal to 3x squared plus 9x minus 30. I have x's on both sides. I'm looking at my like terms. In this case, I have 3x squared and 3x squared. I could subtract that from both sides of the equation. And now I have negative 5x minus 28 is equal to 9x minus 30. Well, now this is quite simple. Right? It's a linear equation. They're first degrees. You could solve this pretty quickly. And if I add 5x to both sides, I'm going to have 14x minus 30 is equal to negative 28. I add 30 to both sides, and it looks like I'm going to have 2 is equal to 14x. I divide both sides by 14, and I'll get, let's write it over here, 2 over 14 is equal to x. Therefore, x is equal to 1/7. Tough problem, long problem, a lot of algebra. So it's mostly practice for your algebra. You could have made a lot of mistakes in here. But if you got 1/7, it's awesome. All right, let's move on to the next section.